Hello everyone, I welcome you all in this course titled Digital Logic and Circuit Simulations. In this lecture we will discuss about decoder and its application. What is decoder? Generally it is a combinational circuit because all the outputs of decoder depends on the present combination of inputs, and a binary code of n bit. Generally in most of the digital system, information are represented in binary codes. There is a need of decoder for decoding a information. Suppose the information is encoded in a binary form, like as a here we use a encoded information. Suppose this the information is encoded like 10011001111, and suppose the information is encoded through a 8 to 3 line encoder, means octal to binary encoder. Then how we decode that information? For decoding we know that we simply make a group of 3 binary bit starting from least significant bit and then decode that information. Here this is what, this is 7, this is 4 and this is 1, and this is also, there are 2 zeros are added here, this is also 1. So, this means this is nothing, this binary information is nothing but a 1147 in octal. So, generally decoder is used for decoding that information. Encoded information is decoded in original form. Encoder is used for encoding that information is binary form. So, this is the octal information, that information is encoded in a binary form, and here the information which is given in binary form, that is decoded in original form, means in octal form, by using a decoder. So, both encoder and decoder perform reverse operation of each other or opposite operation of each other. Decoder has a how many, now the question is how many number of inputs and outputs in case of decoder, and what is the block diagram of decoder? So, generally decoder also consisting of what? There are n number of lines and that decode the information, total m output lines. These are the input lines, and this is the output lines. This is the block diagram of decoder. Block diagram of decoder, or we can say that this is nothing but a n to m line decoder. N to m line decoder. What is n to m line? What is the value of m? Where the value of m is less or equal to 2 to the power n. Means maximum n line inputs are decoded in the form of 2 to the power n line maximum. Means the number of output maximum are 2 to the power n in case of n number of inputs in a decoder, or less number of outputs are also possible, like as when we talk about a BCD to decimal decoder, BCD to decimal decoder. In that situation, BCD is a group of 4 binary bits that are denoted by B3, B2, B1, B0, but only 10 decimals are decoded by using these bits here, 0, 1 and up to 10, like a 0, 0, 0, 9, not a 10, 9 and up to 1, 1, 1, 0, 0, 1. This is the 9, and rest BCD numbers we not know. What is the for BCD? We not know the BCD, and so on. So, in that situation the size of decoder is what? 4 to 10 line decoder. So, generally decoder perform a opposite operation as encoder. Encoder is used for encoding a information, and decoder is used for decoding that information in original form. The number of, this is general block diagram of n to m line decoder. There are n number of inputs. Then in case of decoder, how many possible outputs? Maximum 2 to the power n possible outputs, means the value of output m is either less or equal to 2 to the power n, and the decoder is used to decode the encoded information by encoder. The n to m line decoder has m input n input lines and m output lines when the value of m is, we already discussed it, and for each possible input combination only one output line is whose value is 1 and remaining outputs are 0. This is the important point here, that each possible input combination only one particular output line value is 1 and rest of the output lines values are 0. Means in each of the input min terms only one particular output line is active, rest are non-active. The examples of decoder are like as a 2 to 4 line decoder. When we talk about an encoder, then this is a 4 to 2 line encoder, means 4 line information is converted in the form of 2 binary bits. Similarly, 3 to 8 line decoder, in terms of encoder it is a 8 to 3 line. Similarly, 4 to 16 line decoder, that is also known as a binary to hexadecimal decoder. Like as here when we talk about a 4 to 16 line decoder, so there are 4 number of input lines named as A, B, C and D, A, B, C, D. There are 4 input lines here, and how many output lines? 16 output lines starting from D0, D1 and up to D15, 16 lines, and this is a 4 to 16 line decoder. So when the input values are 0, 0, 0, 0, all input values are 0, 0, this means this particular D0 is equal to 1 and rest are 0, 0, 0. Similarly, when the value of 0, 0, 0, 1, this means this D1 is 1 and rest are 0, 0 and so on. In this way we will, this is the block diagram of 4 to 16 line decoder, or that is also known as binary 4 bit binary to hexadecimal decoder. These are some example of decoder. Here we discuss about a 3 to 8 line decoder. In previous lecture we discussed about a 8 to 3 line encoder. Here we discuss about a 3 to 8 line decoder. This performs just a reverse operation of encoder, means the binary informations are converted, 3 bit binary information are converted in a octal form. Generally we know that what is, suppose how this information is encoded, suppose 0, 0, 1 or 0, 1, 1 or 1, 0, 1. These are the input lines, means these are x, y, z. When the x, y, z, this means what is the decimal equivalent that represents a 1 in octal, this represents a 3 in octal, this represents a 5 in octal. Suppose these numbers are written as 0, 0, 1, 0, 1, 1, 1, 0, 1. This means this is nothing but a 1, 3, 5, it is written in octal. This is the truth table, and in case of decoder only one output line is active at particular moment of time, and we directly derive the output value. When D0 is 1, means D0 is 1 in the combination when 0, 0, only in this unique combination the value of D0 is 1 and rest of the combination the value of D0 is 0. So this means D0 is represented by this particular min terms x complement, y complement, z complement. Similarly, when D1 is 1, D1 is 1 when this in this particular min terms, when this is 0, x, y, z are 0, 0, 1, this means that is represented x complement, y complement, z. Similarly, D2, when D2 is 1, means at a time 0, 0, 0, this means D0 is 1, 0, 0, 1, this means D1 is 1, rest are 0. Similarly, 0, 1, 0 means that represents a 2, D2 is 1, rest are 0, 0, 1, 1, that means here this represents a 3, means D3 is 1, and similarly 1, 1, 1, this means D7, so that particular D7 input output is 1 and rest are 0, 0. So we directly derive the output, means simply the output D0 to D7 are represented by corresponding min terms. D0 is 1 in the combination, only unique combination 0, 0, 0, and that are represented in the form of x complement, y complement, z, means when x, y, z both are 0, 0, 0, then x, y, x complement, y complement dot z complement gives a 1, that means D0 is 1. Similarly, D1 is this. Similarly, D2, what is D2? Output D2, D2 is 1 when x complement, y, z complement. D3 is 1 when x complement, y, z. Similarly, D4, when D4 is 1 when x, y complement, z complement. D5 is 1 in 1, 0, 1, this means x, y complement, z. Similarly, D6 is 1, D6 is equal to 1 when x, y, z complement, and D7 when all x, y, z are 1, 1, 1, then D7 is 1. We directly design the logic circuit of 3 to 8 line decoder. So, here we write a Boolean function, we already write a Boolean functions corresponding to all 8 output starting from D0 to D7. D0 is written as this, D1 is written as this, D2, D3 and up to D7. Now, the question is how we design a circuit diagram of 3 to 8 line decoder. Block diagram of 3 to 8 line decoder, there are 3 number of input lines here, 3 to 8 line decoder. There are 3 inputs are there, 8 output lines, this is D0, D1, D2, D3, D4, D5, D6 and D7. These are the 8 output lines. Now, the question is when these are x, y, z are the input lines, when the value of x, y, this means D0 is active and rest are non-active. At particular moment of time only one output line is high and rest are 0. Now, the question is how we implement the circuit diagram of 3 to 8 line decoder. We know that what is the value of D0. D0 is written as what, x complement y complement z when all inputs are 0 0. D1 is written as what, x complement y complement z. D2 is written as what, x complement y z complement. D3 is written as x complement y z. Similarly, D4 is written as x y complement z complement. D6 is written as, D5 is written as x y complement z. D6 is written as x y z complement and D7 is written as x y z. We implement design a logic diagram here. This is what, this is x, this is x complement, this is nothing but a x complement. Similarly, y, this is what, we connect it by a NOT gate, this represents a y complement. Similarly, this is z, when we connect it by using a NOT gate, this represents a z complement. Now, what is x complement, y complement, z complement? For designing a circuit, we simply x complement, y complement, z complement, this is x complement, this is y complement and this is z complement, and all 3 are connected by using a single NAND gate. This represents a D0, this represents a D7. This is the logic diagram of 3 to 8 line decoder, and previous one, this is the block diagram of, this is nothing but a block diagram of a 3 to 8 line decoder. At particular moment, what happens here, what happens when the particular value of, suppose the value of x is 0, y is 0, z is 0. So, when x is 0 means x complement is 1, this is 1, this is 1, y complement is 1, z complement is 1. So, this means D0 is only active and rest are non-active, because here when we talk about a D1, this is connected from what? This is connected from here z, and z is what? Z is 0, this means whole output becomes 0. Similarly, D2 becomes 0, D3, D4, D5, D6 and D7 becomes, means at particular moment of time, in each input combination or in each min terms only single output line is high and rest output lines are 0. Now, what is decoder with enable input and how we use decoder with enable input? Why the need of decoder with enable input? So, generally when we talk about a logic diagram of decoder with enable input, this is nothing but here there are number of inputs and there are suppose 4 number of outputs here, and there is this is a decoder with enable input E. This is nothing but a 2 to 4 line decoder. There are 2 number of inputs, there are 4 outputs that are denoted at D0, D1, D2, D3. Why we use a decoder with enable input? For modifying decoder, suppose we want to design a 4 to 16 line decoder by using 2 to 4 line decoder, or 3 to 8 line decoder by using 2 to 4 line decoder, there is need of decoder with enable input. Means when particular decoder is enable functional and when particular decoder is not functional. So here when the value of E is equal to 0, this means there is a not, this means this particular enable is, means encoder is functional, decoder is working. When E is equal to 1, E is equal to 1, this means this value is 0, this means the decoder is disabled. Decoder is what? Disabled means non-function, decoder is not function. So, generally decoder may include one or more enable input to control the operations of circuit. Why we use a enable decoder with enable input? Generally enable input is used to control the operation of circuit, means when particular encoder is worked and when particular encoder is not worked. Some decoder are constructed with NAND gates which produces the AND operation with inverted output. Means at when we design a 2 to 4 line decoder with enable input by using a NAND gate, then at particular moment of time only one output value is 0 and rest all are 1 1 1. And the decoder is enabled when enable input E is equal to 0 and only one output is equal to 0. Why? Because here we design decoder by using a NAND gate and all other outputs are equal to 1. The output whose values are 0 represents the min terms, not a mid term, min term selected by input xy. So, simply when output whose values are 0, that represents a min term selected by input xy, and when E is equal to 1, two possible values of enable input, either E is equal to 0, E is equal to 0 means enable decoder is functional, and E is equal to 1 means decoder is disabled. This means the decoder circuit disabled regardless the value of other two input xy, and none of the output is equal to 0 and none of the min term, not a min term, min terms are selected. Means when the value of E is equal to 1, whatever the value of xy, the output is what? The output is always 1, none of the output is equal to 0. Decoder with enable input is also a function as a demultiplexer. Decoder with enable input, generally we know that in a case of demultiplexer there is only single input line and that input line is transmitted over more than means maximum 2 to the power n possible output lines with some selecting input lines. Means the output at particular time in case of demultiplexer, what output line is active, it depends on the number of selection line, and we will discuss the demultiplexer when we start discussion about a demultiplexer. It is a combination, generally what is the general demultiplexer is a combinational circuit that receive information from single line, like as the enable input here, from single line direct it to a 2 to the power n possible lines, and here the selection of specific output lines are controlled by a bit combination of selection line. In case when this particular decoder with enable input are work as a demultiplexer, then these input lines are like as a selection lines and this is like as a input single input line, and this direct information over 2 to the power n possible output lines. Here we take an example of 2 to 4 line decoder with enable input. Generally the block diagram, when we talk about a block diagram of 2 to 4 line decoder with enable input, this is the block diagram of 2 to 4 line decoder. There are two input lines here, these are the inputs and these are the outputs, and there is a one enable input when the value of E is equal to 0. This means decoder is active functional, when E is equal to 1 it is disabled non-functional. The circuit of 2 to 4 line decoder constructed with NAND gates. Generally decoder with enable input circuit are constructed with NAND gate and it is just a reverse operation of AND gate, and here means at particular moment of time or at particular min terms only single output line is 0 and rest all output lines are 1, and that particular output line is corresponding to a particular min term. So, here the circuit of 2 to 4 line decoder with constructed with NAND gates operates with complemented output and complemented enable input. Means when enable input is 0, then circuit behaves. The output whose values are 0 represents the min term, not a mid term, min terms selected by input x, y. So, what min terms is selected? We can select a min term whose values are 0, and when E is equal to 1, the decoder circuit disable regardless the value of other two input x, y, and none of the output is equal to 0, and none of the min terms get selected, min terms are selected. Let us take a truth table of 2 to 4 line decoder with enable input. Generally here enable input, what happens when enable input? We simply design a 2 to 4 line decoder by enable input. Here simply we take a 2 input lines x and y. This is what? X, this is y, here this is y complement, this is x complement. Then when both x, y are 0, 0, which particular min term value is 0? Here this value is 0, means this is D0, and here what happens when enable input is 0? This means this is E, and here this is taken as complement. When E is equal to 1, this convert it in its complemented form, and when E is equal to 0, this means this is 1, this means all are connected here. This is D0 x, y, and here this is E, all are connected by using a NAND operator, NAND gate here. This represents value D0. Similarly here x complement y, here means here we take the value of x, and here x complement, and here we take the value of y, and we third input is taken as a E complement. This is taken from here, this represents what? This represents a D1, means D1 is equal to 0. Similarly, third case is what? X is taken from here, x is taken from here, y complement is taken from here, y complement is taken from here, and E is taken from here, E complement is taken from here, and we use a AND gate here, this represents a D2, and similarly for D3, this is a NAND gate, this is also NAND gate, this is also NAND gate. For D3, what happens here? This is x and y both are taken from here, x is taken from here, similarly y is taken from here, y is taken from here, and this E is taken from as a third input taken from here. This is a D3. What happens when the value of x is 0, y is 0, and what is the value of E is 0? When E is 0, x is 0, y is 0, E is 0, this means what happens here? This is 1, this is 1, this is connected here, this is connected, this is what? X complement, means this is 1, this is 1, and this E is also, this is E is 0, this means this is 1, and this is also 1, this means this is what? 1 1. When all the inputs are 1 1 1 in case of NAND gate, then what will be the output? That is 0. And when at least one input is 0 in case of NAND gate, here in this case the x is connected here directly, x complement, this is x complement, and y is directly connected, means y is 0, and when any one of the input is 0 in case of NAND gate, this means this is 1, D1 क्या हो जाएगा 1, D2 is 1, D3 is 1. So this means which particular output line is active? The output line whose value is 0, that means D0. Similarly, in the case of 0 1, this is 0, D1 is 0. Similarly, in case of 1 0, this is D2 is 0 and rest are 1 1 1, and similarly when 1 1 1 and E is 0, this means this is 0 and rest are 1 1. So, this is the logic diagram of 2 to 4 line decoder with enable input 2 to 4, and how we directly derive here when simply when E is equal to 1, this means whatever the value, this means here the decoder disable means non-functional. When E is equal to 0, when E is equal to 0 means when D0 is equal to what? Decoder is functional, D0 is written as what? E complement, what? E complement, X complement, Y complement, complement. Similarly, D1 is what? E complement, X complement, Y whole complement. Similarly, D2 is what? E complement, X, Y complement, whole complement, and similarly D3 is written as what? This is E complement, X, Y whole complement. This is these are the, we directly derives the input lines when this is 0, when this is 0 means complemented form, when this is what? E is 0 means E complement, X is 0, X complement, Y is 0, Y complement, when this is 0, when this is 0 0 1 means E complement, X complement, Y whole complement, and similarly D2 and D3. This is the logic circuit diagram of a 2 to 4 line decoder with enable input, and in case of enable input, the one of the output line its value is 0 and rest output lines are 1, and when enable input is 1, then whatever the value of input lines means X, Y, the output lines are always 1 1 1, and that is the situation means the decoder is not functional. Generally the application, various applications of a decoder are what? Code conversion is one of the application, like as a we want to convert a BCD code into a 7 segment LED device, or BCD to XS3 code conversion, or we simply implement a BCD to decimal decoder, or we simply implement a 4-bit binary code to hexadecimal decoder, etc. So, this means one of the application of decoder is used during a conversion of code from one number system to other number system, like from octal to, for converting, so simply the code from binary to decimal means BCD to decimal number system, BCD binary number 4-bit binary code to hexadecimal number system, and so on. Demultiplexing or data distribution. Decoder is also used as a demultiplexer, and demultiplexer is used as a device to distribute a data from single line to multiple lines. Data routing is another application of a decoder where very short propagation delay is required during a routing, data routing. Designing of large size decoder using a small size decoder, like as a for implementing a 3 to 8 decoder, for implement a 3 to 8 decoder by using a 2 to 4 decoder. Similarly, design a 4 to 16 decoder by using a 3 to 8 decoder and using a 2 to 4 decoder. Similarly, by designing a 5 to 32 decoder by using a 2 to 4 decoder, or by using only 3 to 8 decoder, and so on. So, this is one of the application for designing a large size decoder with the help of a small size decoder. When a small size decoder is given, we also make a large size decoder. Implementation of Boolean function and other combinational circuits, like as implementation of full adder, implementation of half adder, implementation of binary comparator. We will design these devices or these circuit through a decoder. These are some applications of a decoder. Then the first is, here we discuss the two applications. One is the designing of large size decoder using a small size, and another application is how we implement a Boolean function by using a suitable size decoder. So, first here discuss designing of large size decoder using a small size. Suppose 3 to 8 decoder using here 3 to 8, our target is to design a 3 to 8 line decoder, and here the given chip is what, or given circuit is what, or given device is what, 2 to the power 2 to 4 decoder is given, and with the help of this decoder we design a 3 to 8 decoder. Similarly, 4 to 16 decoder by using 2 to 4 decoder, 4 to 16 decoder by using 3 to 8 decoder, similarly 6 to 64 decoder using 3 to 8, 6 to 64 decoder using 4 to 16 decoder and so on. So, let us discuss one by one how we design a 3 to 8 line decoder, 3 to 8 line decoder using 2 to 4 line decoder. How we implement, this is the block diagram of 2 to 4 line decoder with enable input. How we design a 3 to 8 line. Here in case of 3 to 8 line decoder, inputs are what? Inputs are 3 number of inputs named as what? X, Y and Z. Suppose there are 3 inputs named as X, Y, Z, and outputs are, there are 8 outputs named as what? Named as D0, D1 and up to D7. Suppose these are, at a time only one output line is active. For when we implement 3 to 8 line decoder by using 2 to 4 line decoder, what happens in case of 2 to 4 line decoder? 2 to 4 line decoder, the inputs are 2 and outputs are what? 4. So, this means how many 2 to 4 line, minimum 2 to 4 line decoders are required? In first stage 2 to 4 line decoders are required because there are, we can, our objective is to generate 8 outputs here. So, this means for designing here simply we use 2 to 4 line decoder, and this is another 2 to 4 line decoder, 2 to 4 line decoder, and this simply we know that what happens here, there are 2 input lines, these are also 2 input lines, 4 output lines, these are also 4 output lines, these are named as D0, D1, D2, D3, D4, D5, D6, D7, and simply here what is here, the next is the enable input. What happens here, when here enable input is what? That is the third output. There are 3 inputs in case of 3 to 8 line decoder X, Y, Z. So, here Y and Z are given from here, Y and Z, this is Y is common, from one of the input we provide one of the input of both decoder we provide a input Y, and another we provide a input simply we provide an input Z, and here the third input X is taken as a enable input, and when X is equal to 1, this is enable input, and here this is complement of this, and complement of this is given as enable input of second decoder. What happens here in this case, when the value of X is equal to, suppose this is a decoder with enable input, so when the value of X is equal to 0, what happens when the value of X is equal to 0, this means this particular decoder is enabled. So, at a time when this depends on the value of YZ, which output is active, means whether D0 is active. So, here when X is 0, whatever the value of YZ are 0 0, then this D0 is selected, 0 1, then D1 is selected, 1 0, D2 is selected, and 1 1, D3 is selected as a output. What happens, because when X is equal to 0, this after complementing it, it is a 1, and then again complement it, this is a simply 0. This means this particular decoder not functional, this is only functional when the value of X is equal to 0. Decoder, suppose this is a decoder first, or this is a decoder A and this is a decoder B. So, when X is equal to 0, only decoder A is functional, decoder A is functional, and B is disabled. What happens when the value of X is equal to 1, then decoder B is functional when the value of X is equal to 1. When X is equal, again the value of YZ are 0 0, then this is 1 0 0 means D4 is active, similarly 0 1 D5 is active, 1 0 D6 is active and 1 1 D7 is active. In this way we will find design here. Out of, in case of 3 to 8 line decoder, there are 3 input lines taken as X, Y, Z and 8 output lines. When we implement a 3 to 8 line decoder by using a 2 to 4 line decoder, there is a need of 2 4 line decoder, means that is decoder A and decoder B, and both decoder have a common input that are provided as a Y and Z, both are commonly provided to decoder A as well as B, and third input of 3 to 8 line decoder is X, and this is simply given as a enable input when the value of X is equal to 0, which particular decoder is enable and which is disable. Encoder A is enable and B is disable when the value, because it is connected from a NOT gate, this means the decoder B is disable, and when X is equal to 1, this decoder A is disable and decoder B is functional, means enable, and the outputs, what outputs are active, either D4 or D5 or D6 or D7. So, this is the simple representation of 3 to implementation of 3 to 8 line decoder using 2 to 4 line decoder. Now, the question is how we simply implement a 3 to 4 to 16 line decoder, 4 to 16 line decoder using 2 to 4 line decoder. Four to 16 line decoder using 2 to 4 line decoder. Here how many inputs are there? In case of 4 to 16 lines decoder, inputs are 4 named as W, X, Y and Z. What are the outputs? Outputs are 16 that are named as D0 to D15. D0 to D15. Here in case of 2 to 4 line, when we talk about a 2 to 4 line decoders, how many inputs are there in each decoder of size 2 to 4? There are 2 inputs are there and 4 outputs are there. This means for generating a 16 output, how many 2 to 4 decoders are required at a last stage? There are 4 2 to 4 decoders are required. One is suppose here, that is a first decoder, second 2 to 4 decoder, third and fourth. Here what is decoder? This is a simply, this is a 2 to 4 line decoder. These are input D0, D1, D2, D3. Similarly, D4, D4, D5, D6, D7. Similarly, D8, D9, D10, D11 and similarly D12, D13, D14 and D15. This is a 2 cross 4 decoder, 2 cross 4 decoder. This is also 2 cross 4 decoder. This is also 2 cross 4 decoder and so on. Here we provide a common input to all the decoder that are Y and Z. So, here this is Y is provided as a first input to all the decoder, and Z is provided as a second input to all the decoder, this is y and z, and now the two inputs are remaining. So, again we use for selecting, we again use a one decoder of size 2 to 4. This is again we take a 2 cross 4 decoder here. There are two inputs are there that are named as what? W and X, and when if we want, then we take all the decoder with enable input, and here if not want, then simply decoder input decoder with enable inputs. That means here the output, there are 4 outputs, one output is connected from here, another output is connected as enable input of this decoder, another output of this decoder is connected as enable input of this decoder, and another input is connected as a enable input of this decoder. So, this means here when we use how many decoders are 2 to 4 decoders are required to implement a 4 to 16 line decoder. There are 1, 2, 3, 4 and 5. The total 5 2 to 4, 5 2 to the 2 to cross 4 decoders are required. Full adder or any other Boolean function by using a decoder. So, here the question is how we implement a full adder. We know the Boolean function corresponding to full adder. Full adder produces a sum output and carry output. Sum is written as what? Sum output. There are 3 input in case of full adder, that is written as, suppose the inputs are x, y, z, and this C is also written in terms of x, y, z. This is nothing but what? Summation of, when this produce output 1, this is 1, 2, 4 and 7. When this produce a carry output, this is written as what? This is written as summation of 3, 5, 6 and 7. 3, 5, and this is also written as what? Here that is written as x, x r y, x r z, and this is written as nothing but x, y plus x, x r y into z. This is the carry output, and how we first we find a min terms, in which min terms corresponding to a Boolean function in which the output value is 1, and we write it in this form, means SOP form, and we write all the Boolean function in SOP form, means all the min terms. So, simply we write all the min terms in which the output value is 1, and then we use what is the suitable size. There are 3 Boolean variables to represent a Boolean function. This means we use here 3 to 8 line decoder. Suppose there are n variables are used, n variables are used to represent a Boolean function. This means we use decoder. This means the decoder size is what? Decoder, we use decoder as n cross 2 to the power n, n 2 to the power n line decoder. In this case, there are only 3 Boolean functions are used, there are 3 Boolean variables are used to represent a sum output and carry output. This means we use a 3 to 8 line decoder here, and we know the block diagram of 3 to 8 line decoder. This is, there are 3 input lines are here, that is written as x, y, z, and 8 output lines. Suppose the output lines are D0, D1, D0 here, D1, similarly D2, D3, D4, D5, D6, D7. Total 8 outputs are there. What min terms for representing a yes? There are 2 Boolean functions are represented by this 3 to 8 line decoder. This means how many OR gates are required? There are 2 OR gates are required, and each of here, each output containing a 4 min terms. This means each OR gate have a 4 input OR gate. So, this is nothing but a 1. So, here D1 is taken from here, D2 is taken from here, D4 is taken from here, and D7 is taken from here, and all are connected through a OR gate, there is a 4 input OR gate, this produces a sum output, and for producing a carry output, this is 3, 5, 6, 7 to simply min terms. So, output 3 D3, output D3, output D5, D6 and D7 all are connected through a OR gate. This produces a carry output. What happens here? What happens? What is the full adder? Suppose let us take the example. What happens in case of when all x, y, z values are 1, 1, 1? Then 1, 1, 1 means which one is active? This D7 is active. This D7 is connected as the input of this OR gate, in which C is produced as a output, and also D7 is connected. This means both S is equal to 1 and carry is equal to 1. In this way, we will check this is what, this is a 3 cross 8 decoder. In this way, we will check the all possible combination of input, and what will be the value of S and C. S is the sum of full adder and C is the carry produced by a full adder. Now, suppose we want to implement a Boolean function by using a suitable size decoder. Suppose we implement a Boolean function, simply the Boolean function is written as F1 is equal to BC complement plus CD complement, CD. And suppose the F2 is what? F2 is written as A complement plus C complement D. Now, first we write a SOP, means canonical SOP are standard SOP form of function F1 as well as function F2, means by default here 4 variables are involved. This means this is a 4 variable Boolean function, and this is also ACD, means that means we consider that B is also involved here. This means this is also 4 variable Boolean function. So, this is simply we can written as F1 of A comma B C D and F2 of A comma B C D, and we implement, this is written as what, this means what. Now, question is what possible input combination. So, here first term represent A, B, C, D. For representing a first term BC complement, what happens here? In BC complement, B value and C value are fixed. B value is 1, C value is 0, then BC complement gives a 1. And what are the possible values of AD? That is 0, 0, 0, 1, 1, 0, 1, 1. Similarly, for representing a term CD, here A, B, C, D, this is written as C and D are fixed and rest are changed, A, B 0, 0, 0, 1, 1, 0, 1, 1. This represents what? Min terms M4, M5, M12 and M13. Similarly, this represents a term M3, M7, M11 and M15. This means this is written as summation of 4, 5, 3, we write in a sequence 3 is the smaller min terms, then 4, 5, then 7, then 11, then 12, 13, 15. Total 8 terms out of 16 min terms, 8 min terms, the output value is 1, rest are 0 is added extra and 13 is added this. When we represent suitable size, how many Boolean functions are there? And in this case, each functions there are how many number of inputs? This have a 8 number of inputs for representing 8 min terms in this function, and for representing a function F2, how many min terms? This is 7, means 8 plus 2, 9. So, first there are 2 OR gates are required, because we implement a 2 function by using a suitable size decoder. And what is suitable size decoder? Here 4 to 16 decoders are used here, 4 cross 16 decoder, 4 cross 16 decoder, and the inputs of these decoders are, this decoder are, that is written as W, are A, B, C and D, and what will be the output here? D0, D1, D2, D3, D4, D5, D6, D7, D8, D9, D10, D11 and up to D11, D12, similarly and up to D15. What we have to, for representing this 3, 4, 5, 7, simply take a 3 is here, 4 is here, 5 is taken from here, 5, 7 is taken from here, then 11 is taken from here, 12 is taken from here, and similarly 13 and 15, 13 is taken from here, 13, 14 and 15, 13 is taken from here, and all of these output are connected by using a single 8 input OR gate. This represent a function f1, and similarly we also represent a function f2 by connecting the output 0, 1, 2, 3, 4, 5, 6, 7, 9 and 13, all are connected by a 9 input OR gate, and simply this represents a function f2. So, in this way we also represent a function f2. F2 is what? This means here there are 9 inputs are there, f2, 9 inputs are what? 0, simply 0 is taken from here, 1, 2 and 0, 1, 2 and so on, and similarly last one is what? 9, 9 is taken from here and 13 is taken from here. In this way total 9 inputs are there, 3, 4, 5, 6, 7, 8 and 9. This means total 9 inputs are connected through OR gates, and this represents a function f2. So, this is the way of representing a Boolean function, or simply implement a full adder, because we also write a Boolean function corresponding to output of full adder or full subtractor or binary comparator. We implement it by using a suitable size decoder. So, this is overall about this class. In the next class we start discussing about multiplexer and its application. Thank you very much.